In today's video, we will be solving questions 18 and 19 from the new syllabus Mathematics Book 2, Chapter 2, Exercise 2F. These questions are related to linear equations and their solutions. The solution of linear equations involves finding the true values of the unknowns, which we call variables in linear equations. We have also discussed methods to solve systems of linear equations, such as the elimination method and the substitution method. We have verified the true values for the variables according to the statements of the questions. Now, I am going to read the statement of question 18, which states that two numbers are such that when the larger number is divided by the smaller number, both the quotient and the remainder are equal to 2. If 5 times the smaller number is divided by the larger number, both the quotient and the remainder are also equal to 2. Find the two numbers. The solution to the question is to find the required numbers. First, I will shape this statement according to the system of linear equations. Since we don't know the required numbers, I'll name the larger number as x and the smaller number as y. The first condition states that when the larger number is divided by the smaller number, both the quotient and the remainder are equal to 2. So, if we divide the larger number x by the smaller number y, then according to the statement, the quotient and the remainder are both equal to 2. We can also use the formula, which is dividend equals divisor multiplied by the quotient plus remainder. So, according to the formula, dividend x equals to the divisor y times quotient 2 plus remainder 2. I'll rearrange this equation according to the statement. So, x equals y times 2 is 2y plus 2. Now, to eliminate positive 2 from the right side, I'll subtract 2 from both sides. We get x minus 2 equals 2y plus 2 negative 2. Since positive 2 negative 2 is 0, we get x negative 2 equals 2y. Further, if we divide both sides by y, we get x negative 2 upon y equals 2. This is the equation form of the first statement, which states that if the larger number is divided by the smaller number, both the quotient and the remainder are equal to 2. So, all these steps, which are done in red color, are just for your clarification. You may skip these steps. Now, the second condition of the question states that if 5 times the smaller number is divided by the larger number, both the quotient and the remainder are also equal to 2. The smaller number, which we assumed as y, has 5 times its value as 5y. If we divide 5y by the larger number x, the quotient and the remainder both equal to 2 according to the statement. Using the formula dividend equals divisor times quotient plus remainder, we get 5y, which is the dividend, equals x, which is the divisor, times quotient is 2 plus remainder is 2. I'll rearrange this equation according to the statement. 5y equals x times 2 is 2x plus 2. Now, I want to eliminate positive 2 from the right side, so I'll subtract 2 from both sides. We get 5y negative 2 equals 2x positive 2 negative 2. Since positive 2 and negative 2 gives us 0, we get 5y negative 2 equals 2x. Next, I'm going to divide both sides by x. We get 5y negative 2 upon x equals 2. I'll name this equation as equation 2. Equation 2 shows the second condition of the question, which states that if 5 times the smaller number is divided by the larger number, both the quotient and the remainder are equal to 2. Now that we have arranged both conditions of the question in the form of a system of linear equations, you can solve this system of linear equations by the elimination method or the substitution method. One more thing, as I mentioned before, you may skip these steps that are done in red, because these are just for your clarification and to obtain the system of linear equations. So now back to the solution. I'll take start from equation 1, which is x minus 2 upon y equals 2. I want to solve this equation for the variable x. So step 1, I'll multiply both sides by y. We get x and negative 2 equals 2y, because this y will cancel out this one. Now, to solve this equation for x, I'll add 2 to the both sides. We get x and negative 2 positive 2 equals 2y plus 2. Since negative 2 positive 2 is 0, we get x equals 2y plus 2. I'll name this equation as equation 3. Now, I'll substitute this equation 3 into equation 2, because we are solving the system of linear equations by substitution method. So, equation 2, 5y negative 2 upon x equals 2 becomes 5y negative 2 upon 2y plus 2 equals 2. According to the cross multiplication, we get 5y negative 2 equals 2 into 2y plus 2. Now, it's time to multiply 2 by 2y and by positive 2. 2 times 2 is 4y and 2 times 2 is 4. I'm solving this equation for the variable y, so I'm going to subtract 4y from both sides because I want to eliminate positive 4y from the right side. We get 5y negative 2 negative 4y equals 4y positive 4 negative 4y. Since positive 4y negative 4y is 0, we get 5y negative 4y y negative 2 equals 4. Now, y equals 4 plus 2. If we want to eliminate a negative 2 from the left side, we have to add 2 on both sides. We get y equals 4 plus 2. Now 4 plus 2 is 6. To find x, let's substitute y equals 6 into equation 1. Equation 1, x negative 2 upon y equals 2 becomes x negative 2 upon 6 equals 2. Since we are finding the value of x, so I will eliminate 6 from the left side and I'll multiply both sides by 6. We get x negative 2 equals 6 times 2, 12. Next, I'll add 2 to both sides to eliminate negative 2 from the left side. We get x equals 14. Now that we have found the values of the variable x and y, therefore the required larger and smaller numbers are 14 and 6. You can also verify the values for the variables x and y. So according to the first condition, when the larger number 14 is divided by the smaller number 6, both the quotient and the remainder are 2. According to the second condition, if 5 times the smaller number, which is 6, now 5 times of 6 is 30. If 5 times of the smaller number is divided by the larger number 14, both the quotient and the remainder are 2. Question number 19. A 2-digit number is such that the sum of its digits is 1/8 of the number. When the digits of the number are reversed and the number subtracted from the original number, the result obtained is 45. Find the original number. Now this question is quite different from the other questions. For a 2-digit number, let's take the ones digit of the number as y and the tens digit of the number as x. The number becomes 10x plus y. Here 10x shows the tens digit of the number. Now, to understand the ones digit y and the tens digit x, take a look at this example. The number 53 has its unit digit 3 and the tens digit 5. The expanded form of 53 can be written as 5 times 10 plus 3 times 1. We multiply 5 by 10 because 5 is the tens digit, and we multiply 3 by 1 because 3 is the ones digit of the number 53. Therefore, the original number can be obtained by taking the sum of its tens and ones digits, that is 50 plus 3 equals 53. In the case of y and x, which are the ones and tens digits of the required number, we can obtain the original required number by taking the sum of its tens digit and ones digit, that is 10x plus y. We multiply the tens digit x by 10 and the ones digit y by 1. Then the original number becomes 10x plus y. According to the first condition of the question, the sum of the digits x plus y is 1/8 of the number, that is 10x plus y. Let's name this equation as equation 1. Now, according to the second condition, when the digits of the number are reversed and the number is subtracted from the original number, the result is 45. Now, what happens if the digits of the number 10x plus y are reversed? The number becomes 10y plus x. It is simple that the tens digit will go to the ones digit and the ones digit y will go to the tens digit. Now back to the condition. When the digits of the number are reversed, that is 10y plus x, and the number is subtracted from the original number 10x plus y, the result is 45. I'm going to solve this equation for x and y. So it's time to multiply this negative sign by positive 10y and positive x. We get negative 10y, negative x. Now 10x and negative x is 9x, and positive y and negative 10y is negative 9y. Now if we take common between these two terms, and the common term is 9, we get x negative y equals 45. To simplify further, I'll divide both sides by 9. We get x negative y equals 5. Another linear equation, and I'll name this equation as equation 2. Now that we have formed a system of linear equations including equation 1 and equation 2, let's solve this system by the substitution method. For this, I will take start from equation 1, which is x plus y equals 1/8 of 10x plus y. Now, by cross multiplication, or to eliminate this 8 from the denominator, I'll multiply 8 by both sides of the equation. We get 8 into x plus y equals 8 times 1/8 into 10x plus y. By cancellation property, we can cancel out 8 by 8. We get 8 times x, 8x, and 8 times y, 8y, equals the right side 10x plus y. Now, to eliminate positive 8y from the left side, I'll subtract 8y from both sides of this equation. We get 8x, positive 8y, negative 8y equals 10x plus y, negative 8y. As we know that positive 8y and negative 8y is 0, we get 8x equals 10x. Positive y and negative 8y gives us negative 7y. Since we are solving this equation for the variable x, so let's subtract 10x from both sides. We get 8x and negative 10x equals a 10x and negative 7y, negative 10x. We know that positive 10x and negative 10x is 0. We get 8x and negative 10x, negative 2x equals a negative 7y. Next, I'm going to divide both sides by a negative 2. To eliminate this negative 2 from the left side, we get x equals 7y upon 2. Let's name this equation as equation 3. Since we are solving the system of linear equations by the substitution method, so I'm going to substitute equation 3 into equation 2. Equation 2, x negative y equals 5 becomes 7y on 2 negative y equals 5. We can also write y as y upon 1, and by taking the LCM of the denominators 2 and 1, we get 2. Now if we divide the LCM 2 by the first denominator 2, we get 1. And let's multiply this 1, which is the quotient of LCM and denominator 2, by the first numerator 7y, we get 7y. Again, if I divide the LCM 2 by the second denominator 1, we get the quotient 2. And if we multiply this quotient 2 by the second numerator y, we get negative 2y equals 5. To simplify, we need to multiply both sides by 2. We get 7y negative 2y equals 5y, and the right side 5 times 2 is 10. To simplify this equation for the variable y, it's time to divide both sides by 5. We get y equals 2. To find the value of x, I'll substitute y equals 2 into equation 3. Equation 3, x equals 7y upon 2 becomes x equals 7 into 2, which is the value of y, upon 2. Now 7 times 2 is 14 upon 2. 14 is divisible by 2, which means 2 times 7 is 14. So x equals 7. Now that we have found the values for the variables x and y, therefore the ones digit of the number which we assumed as y is 2, and the tens digit of the number which we assumed as x is 7. Therefore, the original number is 10x plus y. By putting the values of x and y in this expression, we get 10 into 7 plus 2. Since 10 times 7 is 70, and 70 plus 2 is 72. This is the required number. I'll just verify the first condition for your clarification. As we know, the sum of the digits of the number 72 is 7 plus 2 equals 9. Also, if you find 1/8 of the number 72, it's also 9. So the statement is true that the sum of the digits 7 and 2 is equal to the 1/8 of the number 72, that is 9. You can also verify the second condition of the question.